right. Are we ready? Yes? Yes? All right. Testing games in the cloud. Welcome. I am Justin. I'm an engineering manager at Google. And today we're going to talk about testing mobile games in the cloud. So hopefully all of you have seen what we're calling a dory, which was on the previous slide. There's a link in the session page for this session in the app. And with that, you can ask questions. If you haven't been to a session before, you can actually ask questions. During this presentation, you can add questions there, and we will have plenty of time for questions at the end. In fact, I'd even like to open it up to a little bit more than perhaps questions. So maybe understand a little bit more about your experiences with testing of games. But we'll get there. So let's start by asking the question, when we test apps and games, what are we looking for? Well, in some respects, games are just like applications. So we're looking for signals that might indicate a problem or a bad experience, such as slow startup time. Of course, we're also looking for crashes or not responding events, which give a particularly bad experience to the user. We're also looking for incorrect behavior, where the game does not behave as we intend, or indeed as the user expects. But with games, we care very specifically about a number of things. One of these is incorrect or slow rendering. That is because games provide an immersive experience which is thoroughly ruined if your UI is janky or slow. So what are games companies doing today around testing? Well, I've talked with perhaps many of you and certainly a lot of games companies. And there's a whole hell of a lot of manual testing going on. That is manual testing before you release, and then releasing to a whole bunch of alpha or beta customers for a bit of free testing. There is some, not a lot, there is some test automation. But it's usually homegrown, which means it's specific to the perhaps proprietary game engine you're using or to the company that you've built it in. So it's not widely applicable. It's not widely applicable outside of the company in which you work or that game engine. Well, you might be asking, why is this a problem? Well, it's a problem mostly because of expense. You can sort of imagine training all of those testers to not only play the game, but actually to become good at the game so they can get to the later levels, so they can find the issues that your users are going to find some months after you've released into production. And then you have to manually test across a variety of different devices and then verify the results, which of course is even more expensive. And the testing has to be repeated every time you want to release to production. The testing, and this is probably the key part, the testing is also performed particularly late in the process, which means you've no idea which of the myriad of changes your developers have made that could be possibly causing this particular problem. So catching problems earlier is just not possible. And we all know that catching problems earlier makes them easier to fix, as well as cheaper. And lastly, there is no safety net, which means your games developers, or you as a game developer, you don't know if the change you're about to commit is going to break the game in some fundamental way. So why are games companies and developers not flocking to automated testing? Well, it turns out that testing games is frankly really, really hard. So recently, I had surgery, which is why I'm sort of limping around on stage here. And I spent a lot of time lying in bed and did what some might call research, which involved playing a whole bunch of games. Now, I don't actually play games that often, but in bed, I was able to play quite a few games. I also, during the playing of these games, hence the research part, was thinking a lot about how to test these games and how hard it is to test these games. So why is it hard? Well, firstly, games are rendered with something like OpenGL or one of the newer frameworks like Vulkan, which makes them really hard to test because none of the existing testing frameworks that you might use for testing applications will work, like UI Automator or Exitest or Espresso. So these traditional tools don't work. But also, games offer a huge array of possible inputs. You can imagine playing a game like Clash of Clans or World of Warcraft, and you're able to move that character pretty much anywhere on the screen or build that tower in the corner or in the middle or whatever. So essentially, the number of interactions you can have with a game is virtually infinite. And games are often deliberately unpredictable, which means that they give a different experience to the user every time. But that means they give a different experience to the test every time, which makes it very hard to write an automated test. And lastly, issues are harder to reach. Often you have to get to some of the later levels to actually find a particular issue. You can imagine that your ogre on level 10, your favorite ogre, just suddenly died and you've no idea why. Now, up until quite recently, the only generally available option for testing mobile games was monkey testing. And if anybody has had experience with monkey testing, especially of games, you'll know it's not particularly helpful. Rarely does it get very far into the game to be particularly useful. And also, it doesn't exercise the game as a user would. So you may not even care about the issues it finds. It's probably good at finding crashes or issues at startup, but really not much more. So, before we get into actually talking about the solutions, the specific solutions for testing mobile games in the cloud, I need to first introduce our cloud testing platform, which is Firebase Test Lab. This is actually something that I have been working on at Google for about 5 years now. Firebase Test Lab is part of the suite of application quality products within the Firebase umbrella. It allows you to test your app or game in the cloud across a variety of different devices, including, most importantly, some high-end gaming devices on iOS, on Android, on physical devices, as well as virtual devices. You can test in different languages, and you can test in different screen orientations. And with the comprehensive test results that you get, you have screenshots and video, and then the most important part, performance metrics, which we talked about earlier, such as startup time, and specifically for games, frames per second, as well as CPU, memory, network, and so on. Importantly, these metrics are synchronized with the video so that you can tell when your video is displaying whatever's happening in your game, you can tell what's happening with your performance metrics and vice versa. So you can tell, you get some context into whatever problem there is. Also, you get crashes, not responding events, logs, and much, much more. Firebase Test Lab is also, and this is surprisingly unknown, Firebase Test Lab is also the engine behind the Play pre-launch report. How many people here have heard of the Play pre-launch report? How many? 1, 2? Wow, 2. Okay. So in case you don't know, which is apparently 99% of you here, what the pre-launch report is. Pre-launch report is a free report that we give to developers for simply uploading your app or game into a testing track within the Play Store. It's under the release section within the Play Store of your app after you deploy it. It tests your app or game across about 10 devices and gives you the same comprehensive test results. And did I mention it's free? So there's really no excuse not to at least take a look at it. All right, so when I mentioned I talked with a lot of game developers, the one thing that I heard most often from them is security. We heard this from so many of you, that the security of the game is your biggest concern. Much more so than, say, application developers. That is because a leak of a pre-production game would be really, really bad. And that is why we've put a lot of effort, a lot of focus around making sure that the device on which you're testing is completely cleaned up, both before and after your test. So there's no possibility of leaking the game or seeing the results of the game in a future test. In most cases, we simply flash the device between test runs. We also perform a security check on the submitter of the test, as well as the game or app itself. And there you go. I knew I was going to forget. All right. So how much does this cost? I hear you ask. Well, we charge you $1 an hour for an Android virtual device, and then $5 an hour for a physical device, iOS or Android. But the key here is we only charge you for as long as your test runs, which means that if your test runs for, say, 5 minutes on a Pixel 2, it'll cost you about 40 cents. We don't charge you for how long it takes to install your application, to pull off the results from the device, to post-process those results, to ship them off to Google Cloud Storage. We only charge you for how long you specify your test will run. And that's pretty cheap, trust me. So, really there's no excuse not to implement some regimen of automated testing, which brings us to how you might go about doing that, which is what you've all been patiently waiting for me to start talking about. All right. So firstly, and most importantly, you're going to want to prepare your game for testing in the cloud. You may want to create a special version of your game, or you can build testability actually into the code. In Test Lab, we set a property that you can test for. You can then bracket the code in your game by testing with an if statement that simply tests this property. So there are many things that you might want to do to make your game more testable. Firstly, you could focus on the preamble. You could remove some or all of the preamble so that the test can get to the gameplay more easily. You could remove sort of the login part or the registration or something. As I talked about earlier, you probably want to remove the randomness so that the tests that you write are less flaky. They see the same board or game or it can interact in the same way every time. You might want to start the game at a specific level or load a whole bunch of assets into the game so that the game looks like it's been played for a long time. That will allow you to more easily test these later levels or more sophisticated gameplay. And of course, there's probably a lot more that you can do that may even be specific to the game. So with Test Lab, you can run lots of different kinds of tests, some of which are specifically targeted at games. One test that requires little, well, really no effort on your part is Robo. Anybody familiar with Robo here? Yes, all right, we got 2. Okay, Robo is a framework of application crawlers that are used under different conditions. So when Robo sees an opaque screen, such as that rendered by, say, OpenGL or Vulkan or whatever, it will switch to a crawler called the Enhanced Monkey Action Crawler. This crawler today uses machine learning to interpret an opaque screen and identify screen elements on which it can click. Now, Robo shows a yellow circle in the video, which you can see behind me, whenever it interacts or clicks with your app, the app or game. And clicking, as it turns out, on the let's roll here, which is what Robo has decided to do, is exactly what it needs to do to get to the actual gameplay for Mecha Hamster. Now, this is Mecha Hamster. Mecha Hamster, I'll talk about a lot later, but it's a game that we built in Firebase. All right. So Marvin, if we can switch to the demo. So I'm going to do a quick demo of how you might run a test, a Robo test within Firebase Test Lab. So this is the Firebase console. How many people use Firebase here? A few? Oh, that's much better. All right, thank you. All right, so you've probably been down the left nav bar here. Under the quality section, you'll find Test Lab. So we're going to click on Test Lab here. And we're going to run a test. So I'm going to pick from this. I'm going to say I want to run a Robo test. So I'll pick a Robo test. I'm going to browse for my, what happened there? That's interesting. Let me resize that for a second. If that's the worst thing that happens to my demos today, I'll be happy. All right. Anyway, so I'm going to click on this here, which is the Mecha Hamster APK to upload. There we go. That's better. All right. So now this is the Mecha Hamster game. It's going to upload this game into a cloud storage bucket rather slowly, I might add. All right. It's going to upload it into a Google Cloud Storage bucket. And then it's going to allow us eventually to pick from a set of devices on which we want to run this test. So what we will be presented with, and I don't think we'll ever get there, but what we will be presented with is a list of devices, about 100 or so, of different API levels that you can choose from. Now, of course, we have virtual devices and physical devices. For the most part, what we understand from games developers is you only really care about physical devices. So you can pick from the set of Android physical devices. And of course, we have lots of Pixels, lots of Samsungs, lots of different devices that you can choose from, high-end, low-end gaming devices, and so on. And I don't think it's ever going to get there. So then you pick your locale, you pick your screen orientation. And so since it's never going to get there, I'm going to select here and go to the thing I ran 2 days ago from somewhere where they had a little bit more Wi-Fi. And these are the test results from that run. It's a Robo test across 3 different devices, APIs level 26, 27, and 28 on a Pixel 2. So very quickly, we can take a look at the test results. Now, you have full access to the test results. There's even a way to get to the raw test results, which are just files in a cloud storage bucket. But we got here sort of various statistics about the crawl. We have logs. We have screenshots here. It's a Unity game, so there's there. And we'll eventually get the screenshots. And, of course, we have the video and the performance metrics here. And you can see here the video, which I'll actually start playing here. The video, it probably won't come through. But you can see that we have all the different metrics associated with the video. And as the video plays, which it probably will never do, there'll be a little gray line that comes across the screen to tell you where you are within all of the performance metrics. So this is very, very important. And frames per second here shows you the graphics here shows you there's a dip here at the beginning. You may be concerned about that, but anyway, you get the context for the results. All right, let's switch back to the slides, please. All right, with a little bit more effort, you can actually record test scripts. So last year at the Games Development Conference in San Francisco, we announced a partnership with NetEase. NetEase is one of the largest games development companies in China. They had previously built an integrated development environment called AirTest, which they used internally for testing their own games. So they, at the Games Development Conference, they released that development environment to the world. They also open sourced a couple of different testing frameworks that they use for testing their own games. The first is called AirTest, like the IDE, and involves image recognition. So you can simply select an image that you wanted to recognize and then interact with that particular screen element. The second, and probably more importantly, is called Poco. Poco is actually built into the game engines. So it actually publishes a hierarchy of screen elements, which allows you to interact directly with the screen elements from within the IDE and from within your test scripts. So Poco has support for Unity and Cocos and also the Android framework itself. So you can record scripts with the game running locally. I'll show that in a second. You can then package those scripts into an instrumentation test that you then are able to run across a variety of different devices in Test Lab. And the great thing about all these test scripts is it's incredibly easy to go back in and re-record them if, for some reason, your UI or your images change. All right, let's switch to the demo. Marvin, please. All right, so this is AirTest. This is the integrated development environment. And I have Mecha Hamster, which is the game I mentioned earlier, running locally on this device here. I probably shouldn't pick it up. So what I'm going to do is I'm going to show you how easy it is to build up a script. So I can, for instance, say I want to touch this area of the screen. And we're going to use air test here. And it will now attempt to recognize that image and click on it. And then I can say, well, I want to wait for something to appear. So I'll select another part here. So as you can see, I'm building up a script by interacting with my game that I can then test across this device running locally, or under this strangely named menu item called Overseas Devices, I can build this into an instrumentation test that I can then run across all those devices that I want to run them on inside of Test Lab, which gives you the ability to write these test scripts and then test them on the devices your users have. All right, Marvin, if we can switch back to the slides. And if you want to learn more, I'll step out of the way just in case. These are some links. There's the GitHub project on where AirTest resides, and that's the link for where you can download the IDE. I'll let you take a photo. There we go. All right. So the third option that I'm going to present today is called game loops. We introduced game loops probably a year and a half or so ago. Game loops provide a way for you to define one or more critical user journeys through your game. So you could, for instance, focus and have a critical user journey, a game loop, for every level in your game. Or you could focus on every character in your game and write a game loop for that. You can have any number of these game loops and built into your game. So Mecha Hamster, which you can see behind me, is an open source game that you can find on GitHub, which we built to test out many, if not all, of the features of Firebase. So it has real-time database, it has auth support, it has lots of different, uses lots of the different tools within Firebase. But it also has a game loop built into it. All right. So I'm going to quickly demo how we built this game loop. Marvin, if we can switch again to the demo. So I may not have mentioned this, but Mecha Hamster itself is a Unity game, which means we built it within Unity. And I'm going to talk a little bit about how we did that. So I'm going to put up some code here. All right. So the first most important thing about game loops is that they need to be declared. They need to be declared, in this case, in the Android manifest. And you can see a number of lines here that's important to highlight. So you need this part here, basically talking about setting up the metadata for the test loop. You need, for every test loop, you need an intent filter that declares the test loop. And that's down there. So now you've set up and declared these within your Android manifest. The way we built game loops in Mecha Hamster, and this is not the only way you could build game loops, but it is the way we built it within Mecha Hamster, and it's particularly easy to set up within Unity, is we have a special mode of the game that records all of the user interactions or the events with the game into a file. So this gameplay recording enabled equals false. When we set that to true, Mecha Hamster will start recording events into a file. We can then take those events and load them in as an asset within the game. And I'll show that a little bit here. So, and then when the game starts up and it's asked, this is actually the gameplay recorder class, that basically records the events and puts them into a file, serializes them out. When the game starts up, you can test whether you're running in a game loop and then load those assets and simply replay these events. Now, as I say, that's not the only way you can build a game loop. You could build it out of code if you wished, just simply calling function after function. But this is a pretty easy way to do that. All right, Marvin, if we can switch back, please, to the slides. All right, and if you want to know more about game loops and how you might build game loops, there's a rather long link. All right, so I've presented 3 separate automated testing mechanisms. So let's talk a little bit about how you might use each of these different testing, how and when you might use each of these different testing mechanisms. So firstly, talked about Robo. So Robo is really good for testing the preamble to the game. So it follows through the menu items, logging in, registering, all of that kind of stuff. It's also really good if you don't have any tests yet. So maybe you're starting off with an initial version of your game, you haven't written any tests, you just want to test it. First internal version that you want to play with. What we see application developers doing with Test Lab is using Robo as kind of a last-ditch smoke test signal before you push to production, so that you can make sure by looking at the test results, looking for crashes, not responding, whatever, looking at the screenshots, the video, make sure that you've not done anything stupid. Air test, what I presented second, great for testing specific critical user journeys. So, it's good for the UI navigation. Apologies for that. It allows you to test basic gameplay, allowing you to interact with the game. Game loops are really good for testing the critical user journeys through your game. And because it's the same critical user journey each time, it's really good for catching performance regressions. So you can test, you can show that your performance is not degraded in between releases, and you can look back over the previous releases and see how long did this critical user journey take to run previously. And lastly, of course, we're not trying to take over all the manual testing, at least not yet. Manual testing is still really useful for complex interactions such as multiplayer, or indeed some of the late level testing. So, as I always like to say, now with all of those tests that you've written, all you need to do is upload them into a continuous integration system, and every time you make a change, you can be much more confident, we're talking about the safety net here, you can be much more confident that you did not break the game in some obscure way. Which means that your developers are happy, they have that safety net, they know that for the most part, every change they commit, they can tell if it's going to break the game in some fundamental way. So they're happy. Your users are happy because they're not seeing the kind of issues that you're catching with all of these tests, which is, of course, ultimately what we want. So, in summary, obviously, I hope that you take advantage of the testing tools that I presented today. It's like a given. These tools allow you to test with Test Lab across a variety of different devices, the sort of devices that your users are using today. But I also want to talk a little bit about the future. Because as we've heard from so many of you, What you really need is for us to be able to test your game as your best manual tester can. Now, it's a hard but exciting destination to reach, and we hope to see you there. In the meantime, I wish you luck building the best game ever.